Alright, let's see if I can finally put sound to this video. So what I'm really trying to find on this number 24 is UV and RV. And I'm going to use TV and RT to find RV by subtraction. And once I find RV, I'm going to find UV because it's all on that same little triangle over there that I just outlined in blue. Alright, so to find TV, I know the opposite and I'm trying to find the adjacent. So I'm going to use tangent. So I'm going to do tan of 40 equals 45 over, we'll call it x. And then we're going to cross multiply. Right, and then when I solve that, I get x. When I skipped a couple steps, but in the end I'm going to do 45 divided tan of 40. If you cross multiply, you're going to end up dividing. So TV is going to be a distance of 53.6 centimeters. And now I'm going to find TR, which is that whole distance. So I'm going to call that Y. And I'm going to be using that 20-degree angle now because it's on that big, the whole triangle. So tan of 20 equals 45 over Y because it's the opposite and the adjacent. So I'm going to cross multiply, and again, same concept as before. So I'm going to find that TR is a distance of, when I type it in my calculator, oopsie, type 220. Fix it up. Alright, 123.6. So now I found TV and TR. To find VR, I'm going to take 123.6 and subtract TV, which is 53.6, and get the leftovers, which is going to be 70. So RV equals 70. Now that I know that RV is 70, that's the hypotenuse of that little blue triangle. So I know the opposite and the hypotenuse because I'm trying to find UV. So I'm going to use sine. So I have sine of 20 equals, we'll call it Z over 70. Alright. And so I'm going to get Z to equal 23.9. So that's really what UV equals, 23.9. So I found RV and UV, and I had to find a couple other values in the meantime, but still got there. There are other ways to solve that one, but that's the best way I found to do it. If you find a different way, it doesn't mean your way is wrong as long as you get the same answers. So now I'm going to look at 25, and it says find the length of each diagonal of a parallelogram. And the easiest diagonal to find is that one I can't draw straight. So I'm going to redraw it. So that's the easiest one to find. And I'm going to use that blue triangle, and I see side, angle, side, so I'm thinking law of cosines. So I'm going to set it up as x squared equals 62 squared plus 118 squared minus 2 times 62 times 118 times the cosine of 55. And since I know the angle, I can just type that straight into my calculator and solve, and at the very end all I have to remember is to square root. So I'm going to go type this all into my calculator. And I get 9,375.4. And at the end, don't forget to square root that. Doesn't make sense that the side is 9,374. So when I square root it, I get 96 point... I think it's 96.8. Yep, 96.8. Now that makes sense in relation to what our other values are. 62, 118. Makes sense. So now we're going to go down and find the other diagonal. And the issue is that I'm going to no longer know the angle until I find it. So I'm going to move this over so it's out of our way. Right? So I no longer know the angle when I draw on the other diagonal, but I do know that the opposite side is still 62. Now what I have to remember is that angle is 125 because I'm going to do 180 minus, 180, not 185. 180 minus 55 because consecutive angles in a parallelogram are supplementary, meaning they add to 180. So I get that to be 125. And now this is virtually the same problem that I just wrote in blue, except my angle now is 125. So the only thing that's going to change, instead of doing the cosine of 55, I'm going to do the cosine of 125. And again, since I know the angle, I can type that straight into my calculator. So type it straight in, multiply it all out in the end, don't forget to square root. So I get 161.7 for my other one. And that makes sense as the bigger, longer diagonal, 118, 62, logically. If you get an answer like that, it makes sense. So now we're going to move on to our word problems. So we got about 4 problems left. Okay, so this one says, find the measure of the vertex angle in an isosceles triangle whose sides are 12 centimeters and whose base is 16. So that means the two sides are 12 centimeters, and then that base is 16. And what it means by the vertex angle is the angle up top, non-base angle, basically. So we're going to call that x. And I see side, side, side. So I'm going to be using law of cosines. So when I use law of cosines, the only thing I need to figure out is what's my c value. My c value is across from the angle I want to find, so it's going to be 16. So I'm going to do 16 squared equals 12 squared plus 12 squared minus 2 times 12 times 12 times the cosine of x. I know, it's a long formula. We can handle it. Right, now the difference with this one is that I don't know the angle, so I can't just type that into my calculator because that's connected by multiplication. So I'm going to just start simplifying what I can. So the 16 squared, the 12 squared, the 12 squared, and then 2 times 12 times 12. And I get... So when I start simplifying, I'm going to realize that I can't add 144 plus 144 minus 288. I can add the 144s together, but I cannot keep subtracting because there's multiplication on this side. So I'm going to subtract the 288 to the other side, and I get negative 32. So negative 32 is equal to negative 288 cosine of x. Now I'm going to divide that negative 288 because it's connected by multiplication. Right, so when I divide, I get a decimal of 0.1 repeating. And whenever you get a decimal and you think, oh, I'm done, you should probably think, oh, I still probably need to inverse that, because if I get a funny decimal, it doesn't make sense that my angle is 0.111. And whenever I'm solving for an angle, the opposite, to undo cosine, I need to inverse it. So I'm going to go to my calculator and type cosine inverse of 0.1 repeating, and I get 83.6 degrees. Now that's a more logical answer, 83.6. Okay, so that's my vertex angle. All right. Now we're going to move on to our next word problem, which is about a Coast Guard patrol boat has spotted a hovering helicopter dropping a package near the Florida shoreline. So there's our helicopter. It's a lovely picture. I'm quite the artist. Right? And then it says, Officer Sandy Shore measures the angle of elevation to the helicopter to be 15 degrees. So Sandy's standing on shore over here. And the angle of elevation from Sandy, there's Sandy, is 15 degrees. So remember, angle of elevation is if you draw the horizontal on the bottom and then slant up. And then it says the helicopter is 100 feet above ground. So that's that vertical distance. What it wants us to find is how far is the patrol boat from the point directly beneath the helicopter. So I guess Sandy's not on shore. She's in a patrol boat waiting for the package to drop. We want to know how far Sandy Shore has to get that patrol boat to underneath the helicopter so the package can be dropped. So that's that horizontal distance x. So since I have the opposite and the adjacent, I'm going to use tan of 15 over 100 equals 100 over x. Then I'm going to cross multiply. And in the end, I just have to go to my calculator and type 100 divide tan of 15. And I'll find that she's 373 feet away from the point directly below the helicopter. Right. Alright, we have 2 examples left. Let's hope that there's sound to this, so I don't have to try it for the 4th time. Having a lot of technical difficulties. Oops, I went backwards. Oh goodness, if I could get this done with, that'd be nice. So this one is one of the most straightforward word problems you're going to have. A ramp was built by a loading dock, and the height of the loading platform is 4 feet. So that's that vertical height right there. And this is a nice problem because it's a right triangle, just like the last one. We haven't had to do any law of sines, law of cosines. So it's 4 feet up. And the angle it makes with the ground is 32 degrees. So that's the angle right down here. And I want to find how long the ramp is, so how far something would have to travel to go up the ramp. So that's the x. So I know the opposite. I'm trying to find the hypotenuse. Since it's a right triangle, I can use trig, so SOHCAHTOA would give a sine of 32 equals 4 over x. And again, we've done so much cross multiplication. I'm going to skip a couple steps. Well, I changed my mind just in case someone wants to ask me. Here's my steps up here. I would get x times the sine of 32 equals 4, and then sine of 32, remember, is just a number. So I'm going to divide it. Okay. And I'm going to type it in my calculator. So the ramp is about 7.5 feet long. Right. And now we're to our last word problem. Let's hope the sound works on this. 2 kids spot Superman flying in the sky. One spots him at an angle of elevation of 55, and another, standing 20 feet away, spots him at an angle of elevation of 62. Now the issue with this problem, we don't know if Superman's way off to the right or if he's like in between the two. So when I first read it, I thought he was in between them. So here's the picture I would set up. Now what you're going to find at the end, my answers really don't make too much sense. So I'm going to show you a second way to solve this one after I do this. So there's student A with a 55-degree angle of elevation, then student B is 20 feet away, and notice Superman is in between them. Okay, so I need to find 3 values here. I need to find how far away student A is, how far away student B is, and how high up in the air Superman is. So I have x, y, and h that I need to find. To find x and y, I need to find that top angle because I'm going to use law of sines. So when I subtract 1 from 180, 55, and 62, I'm left with 63 degrees. So I'm going to set up sine of 63 over its opposite side, which is 20, is equal to sine of 62 over x. I'm going to go ahead and set up the other one too. Sine of 63 over 20 is equal to sine of 55 now over y. And I'm going to cross multiply, and that'll give me the distance each student is away from Superman. Okay, so I type that in my calculator when I cross multiply, and I'm going to find that the student standing by the 55-degree angle is 19.6 or 19.8 feet away from Superman. And then when I cross multiply the other one, I get y times sine of 63 equals 20 times the sine of 55. Now remember, 20 times the sine of 55 is just a number. And then so is sine of 63, so I'm going to divide that over so I get y alone. And when I type that all in my calculator, I get that student standing by 62-degree angle is 18.4 feet away. And the last thing I need to find is the height that Superman is in the air, so that vertical distance, that means at a right angle. Now I'm going to use this black triangle. It doesn't matter which one I use, but I'm going to use that right triangle that has 62 degrees in it. And I'm trying to find the opposite, and I know the hypotenuse, so I'm going to set up sine of 62 equals h over 18.4. Ooh, I'm having technical difficulties across the board. I can't type in my calculator. I can't get sound to work. Oh. Alright, so I get that Superman is 16.2 feet in the air. Now, these are all answers that I could be validated. However, Superman's probably not going to be 16.2 feet in the air. Alright, so I'm going to get a new page here with this problem and show you another way to do it. This is probably a better way. Right, it's a little bit more tricky, not much. Right, so here's student A, and he's still standing 20 feet away from student B. Except now Superman's going to be way off to their right, up in the sky. Okay, the angle of elevation is still 55 from student A. And the angle of elevation is still 62 from student B. And now I have two right triangles happening here. Except the only issue is I don't have enough information on those right triangles to find anything yet. So what I'm going to do is use that red triangle right there and use law of sines to find out what the shorter side is right there, because that's the hypotenuse on the other right triangle. And once I get that, I can use that to find it. So I subtracted from 180 to get 118. Excuse me. And then I added 55 and 118 to get 7. So what I'm going to do is set up law of sines because I know 7 degrees and 20 is its opposite side. So I'm going to do sine of 7 over 50 or over 20 equals sine of 55 over its opposite side, which is the one I want to find, which is x. So I cross multiply, and that's really going to give me oh, excuse me, the distance student student B is from Superman. So when I cross multiply, I'm going to end up doing 20 times sine of 55 divided by sine of 7 in my calculator. And I get that student B is 134.4 feet away, which makes more sense than our last answer, which was, I think, 19.4 feet, right? And now I'm going to use that hypotenuse there and this triangle that I'm outlining in green. So I'm going to use that 134.4 on that green triangle and find x. It's a right triangle with the opposite side that I'm trying to find. I know the hypotenuse is 134.4. So I have sine of 62 equals x over 134.4. And what that's going to give me is the distance or the height that Superman is in the air. And so what I get is that Superman is times by 134.4, 118.7 feet in the air. Right? And now what's nice about knowing that is I now have a side on that big right triangle. Okay, so I ultimately need to find now how far student A is from Superman, that distance y that I just wrote in. And so what I'm going to use is this big triangle. And I'm going to outline in black, so that big triangle right there, I know the opposite side. I know the angle is 55. I know the opposite is 118.7. I'm trying to find the hypotenuse, so I'm going to use sine. Sine of 55 equals 118 over y. And then I'm going to cross multiply. And I am about done with my final answer. Just need to do my calculations. I'm going to go to my calculator and do 118.7 divided by sine of 55. And I finally found my last value, which is 144.9. So student A, which is the farthest away from Superman, is 144.9 feet away. So to recap this, I used lying on a line to get the angles, and then used the law of sines at first, and then just used right triangle trig to find the rest. So I found that hypotenuse, which is 134.4 from student B to Superman. Then I found the height Superman was in the air using trig, right triangle trig, and I got 118.7, and student A I found last to be 144.9 feet in the air. Hope this helps. I hope this has sound finally for you to at least get something done on page 4 tonight. I will see what I can fix in the morning. Have a wonderful night.